here. There's some people.
Okay.
People are slowly filtering in.
Okay.
So good morning, everyone. Thank you so much. Thank you for joining us. We're recording this, so we'll be able to share it with some other folks. And I see some folks are coming online as we start. So we had to do an extra earlier time to accommodate John's schedule. John is on the West Coast, but he gets up at an incredibly early time on the West Coast to facilitate us. So we want to really thank him for this. So what can I say about John and his career? Every time I talk to John, he drops a name that was like huge for me back in the day. Like we were talking recently, he said, "Oh, Scott Guthrie," and I'm like, "Scott Guthrie?" Like I used to remember when Scott Guthrie would say things, and I would literally be running to the internet to read whatever he said because I was an ASP.NET developer back in the day. So it was just like, so all of these projects, Silverlight, MVC, all of this stuff, Scott Guthrie was right there. And John just casually mentioned Scott Guthrie. And I'm like, what? You knew Scott Guthrie? So, but not only that, he has a tremendous background in research, tremendous background in the startup community. He worked at, I'm guessing, is it just Microsoft and Google that we know of the major ones that,
Samsung Research.
Yeah. Oh my
Vib
God.
Labs, my own startup, Broadvision. Those are the big ones.
Yeah, Broadvision. Oh my God. Yeah.
Yeah. That was a long time ago.
Yeah, I have so many questions. So yeah, John has a background in research and determinism and security. And so we are really gracious to have him here to talk to us about what it's like for the AI security landscape. So take it away, John.
Yeah, absolutely. Thank you. Thank you for having me. My interactions with sort of the Northeast have increased markedly over the last period of time. It's been great interacting with sort of Boston and now Philadelphia and the broader area. So this is a privilege for me certainly to present to you today. I generally do deliver this talk to. Now I see it says sort of Ben Franklin SIP 6. So is this a series that y'all are doing, or what's sort of the?
Yeah, this is the 6th in a series of sessions that we've done, and
okay.
So we've done a session with Uday, did a session, David did a session, and I've done a couple of the sessions, and then also we had Isaac, who's from our CE team, who did a session as well. So this is the 6th in the series.
Amazing. Wonderful. Okay. So it is relatively challenging material today. I will tell you that. I generally deliver it to researchers, but please ask questions. It is accessible, but please, if you do have questions, this time is for you. I have what I think is interesting in my approach to AI security, but and particularly with this size of a group, feel free to make this conversational. We have plenty of time, and so if it's sort of directionally correct, I would just keep going. But I kind of get ahead of steam going, so please feel free to either raise your hand in the tool or simply come off mute and onto voice and ask. I do show some exploits. Please do not use these. They will get your account banned. I use them in controlled environments on systems which I have permission to do so for the purposes of research. Some of them contain profanity. I usually don't use exploits against the most current versions of various things, but they are out there to find them. They're simply here to sort of make a point. And in general, when we analyze public artifacts for vulnerabilities, it's to find where the security boundaries are. And today I will talk about the primitive of the model and where the security boundaries live when you make compositions. Generally, startups are doing agentic compositions, in other words, building agents on top of models. But any system that uses a large language model based on a transformer, and we'll go fairly deep into the mathematics of and functionality and the mechanics of the transformer itself. At inference time, I will say up front, this is generally inference time. Training time is very different, and so I don't do a lot here on that subject, only to reference what happens at training time, but I don't do much of the mathematics. So to sort of begin and set the tone, this actually does work. Again, please don't do it in your account; you will get banned. But the point of this is that the primitive here is supposed to be a translator. But what the translator decided to do was take part of the text and act on that text as if it were policy or an action. So you can see here, there's some Mandarin, and then an injection of a request, and the model simply answers the request and tells me how to make ricin. Probably not what the builders of Google Translate wanted it to do. So this is the injection, quite simply made. So this is not complicated. It's not magical. It's not some sort of set of strings that look arcane or impossible to reproduce. It is simply enough tokens to condition the geometry to result in a continuation that is not likely what governance wanted to have happen. And the reason for this is, I will argue today, that the boundary, the security boundary, and this sort of continuation cannot be enforced by the model itself. It is required that we enforce this, the boundaries that we want and the governance that we want in the agentic composition, in the engineering that we do on top of the model primitive. So, and that will be my argument to you today. As Len said, I just know all these people because I'm old. I'm old, I've been around a long time, so I just meet people when you're old. But my first startup was in 1996, Broadvision. We went public. After 9/11, I founded my own startup in the security space. I worked with Department of Homeland Security, which was Department of Nuclear Detection at the time, DNDO, and Department of Energy on radiation detection. So we built radiation detection devices and algorithms using machine learning to detect dangerous radiation potentially coming into the countries through airports, seaports, and we also deployed in military bases around the country and the world. We were acquired by a defense contractor. After that, I worked at Microsoft in Azure on machine learning with our customers. I worked for Vib Labs, so we built the conversational assistant that became Bixby on your Samsung phones. So we were acquired. Sorry about Bixby. That's not what Vib was intended to do, but when you buy stuff, you get to do what you want with it. Anyway, I worked at Samsung Research building models. We were moving Viv over from heuristic AI to generative AI and building our own custom models at Samsung Research. And now I have the privilege to be a global founder advocate along with my good friend Len here. And our job is much, much simpler. It is help create success for founders such as yourselves in partnership with Google. That's what we do. That's all we do. We care about your success. And that is where the majority of our time is spent. And so it is our goal to, when you're a $5 billion company, you get up on stage and say, gee, I'm really glad I met Len way back when. He played a part in getting us here. And that's the payoff for us. You can see all the research I'm able to publish and my patents at Stable Geometry. Generally, my background is in differential geometry and control theory, so that is the lens I will take these things in. And my career has been around sort of adversarial machine learning and adversarial now AI, and the mathematics around that. Today, we're talking about AI security, not in general security posture, cybersecurity, that is separate from this, and not in general what one would refer to as AI safety. So the conversation here is sort of not about changing the likelihood of continuations. That's sort of AI safety, post training and system prompts and all that good stuff to make sure the model doesn't talk about, whatever they don't want it to talk about, CBRNE, for example. But instead, where the security controls are, what we can control, where our roots of trust, what we can rely on, what we cannot, and where our vulnerabilities are. And I will argue this is motivation for the notion that that many projects attempting to compose on top of the model fail. And we'll talk about that in a moment. My research is around making jailbreaks impossible. However, that is not the truth today. So instead, I talk about making jailbreaks structurally irrelevant. So building enough engineering around these primitive components such that we can control when they get compromised, what happens, because they will get compromised. And we need to know when that happens, what that happens, and we have to have the most robust defensive posture that we can in order to deal with those issues. And there's a whole series of sort of engineering steps I'll talk about and things you can actually do to help deal with the notion of a lack of root of trust here. But that is basically my goal. 2025 was the year of agents. It was the year of failed agents. And I pulled out these random and fairly well-known studies, but if you don't like them or the methodologies they're in, you can find 100 different other studies about failing to deploy models, failing to deploy agents, difficulties with agents. You deploy them, everything works first, and then as they encounter hidden control edges in your environment, as they encounter many different contexts and tokens, they drift away from proper, what we would consider proper operational guidelines, and sort of drift off into whatever it is they do. And this has resulted in a whole lot of failed agent projects. If you have felt this pain, then you will understand precisely what I'm talking about. Sort of in all transparency, if you haven't felt this pain, this might seem like sort of a lot of useless theory to you, but if you have tried to deploy agents in the real world, you have probably seen them behave differently than you expected based upon evals or testing, and we'll discuss precisely why that happens. My general thesis is that the model capability has outpaced our ability to compose, govern, and deploy around it. We are all running very quickly to get these things into production, and we haven't done what we have done with software, in that we have spent the last 40 years in software engineering dealing with the fact that software fails.
Hey, John.
Yes,
Just
question.
a quick item. So a good number of folks who are, half of our portfolio here is in the healthcare space.
Okay.
So they have a lot of, HIPAA and a lot of, proprietary data. And then we've also got a couple of folks who are either on the call or will be listening to the recording, who are in more like financial services. Holly has joined us. She is with, she's in the benefits space, so also access to a lot of, important data.
Yeah.
So I think for, just to kind of give you an idea where folks are coming from in this call, like some people are definitely like, full steam ahead. They've been using AI. They are an AI, AI native company, if you will. But other folks are trying to figure out how they want to implement AI. And that's why we really wanted to have this session as part of our 6-part series, because folks are trying to figure out where they can pick up business efficiency in a safe way, but also be really discerning around where and when they're using it. So I just wanted to give you that little bit of, where folks are coming from as a part of this call. And I think when people see this slide, they have questions around, should we wait a little bit, or should we be playing with it in certain areas that are maybe like ring fenced from other other data that we have here. So just wanted to throw that out there.
Yes, thank you for that, Colleen. That's great context. I can sort of talk to that actually right now. It's not necessarily that. First of all, it's excellent that they're in healthcare and fintech. Both of those verticals are directly in the lens of security for one reason or another. Fintech obviously is the most attacked vertical. If you look at the Mandiant report from 2026, you will see that fintech is the most targeted vertical for attacks. So security is primary, and as you deploy these components into your environments, it's critical to think of a security first, robust posture. In healthcare, of course, like you said, we have tons and tons of very private data, HIPAA compliant data residency requirements. We work with data that we need to protect constantly in healthcare, and so that's absolutely a great vertical that can benefit from some of the information here. I will tell you, it's not necessary to wait. Both of those industries and enterprise in general is going slow. I think we all know this. If you've tried to sell into the enterprise or tried to get customers that are enterprises, especially in healthcare, they will be very slow to adopt AI. They will be some of the last. And that's for good reason. It doesn't mean we shouldn't be doing things right now. It means we should be doing things with a thoughtful security posture, understanding what the models are and what they are not, and how to build compositions and software engineering around them such that they can be successful in any environment, but in particular, highly regulated or regulatory environments. Does that make sense as sort of motivation for your point? Yes?
Yes, thank you.
Okay, great. And there are some, I can sort of cut over to some architectural guidelines that might be more helpful. Let's do a little bit and see if it's resonating, and if not, I do have some information that might be more practical while building agents, for example. That might help. But the basic theory here is all pretty standard, and it is the same as the other kind of talk. So there's a whole sort of just a set of introductions. If it is too math heavy, just let me know. And we can sort of move to an architectural level if that would be more helpful. I will say we will not be blaming our failures on ghosts. We will not be blaming our failures on hallucinations. There are no gremlins in the walls. We will be doing solid engineering. We will be defining the mathematics and the behavior of the models, and we will do software engineering and proper engineering around them. The community is giving you terrible intuitions. Models don't hallucinate. There is no perceiver. Models don't deceive. They don't lie. They don't get confused. They don't invent. All of those intuitions are incorrect. And they absolutely send you down the wrong engineering path. Do not use them. Do not adopt the intuitions of the community. They are ridiculous in most cases. There are no spirit people running around the internet. Models work on mathematics, and my framing is control theory. So these are not anything magical. They work how they work, and we will define how they work. If you misname the mechanism, you misplace control. Okay, so we will talk about things that we can define and reason about, and we will put control in the right place in engineering. This is the framework I generally use. This is extremely standard transformer notation and design, with one exception. Sort of the middle box is motivated by my own research. I bring it in here, not in full sort of full rigor, but to answer just sort of an idea about the full state needed to continue the generations of the model. But in the model primitive is what's important here. And this is the reason I put this here is because this is the piece in our architecture that we cannot decompose beyond. In software engineering, one of our biggest tools to deal with difficult problems, complex problems, complexity is decomposition. We break big problems into smaller problems. Well, we can only break this down as small as the forward pass. Forward pass cannot be predicted. In order to know what logic comes out of the forward pass must be run. So there is nothing from an inference time perspective. Again, there is nothing that we can do to break it down further than that. So we must live with the model primitive, and everything around that is composition and engineering. I'll use a GPTism here. C under K is admitted context. Why do I say that? Admitted context. And the GPTism, chat GPT is admitted is doing a lot of work here. Yes, admitted is doing a lot of work here. And that's because what you type into the box is not what reaches the model. When you send tokens to an API, that is not what enters the context. There are many, many, many layers between entering, either calling an API, entering text into a text box. That is not what reaches the context. There are policy layers, there are edits, there are the system prompts, your system prompt, the provider system prompt, all manner of guardrails and policies that perturb and change the tokens that actually enter the geometry, that actually influence the continuation. So admitted context is important here. It's not precisely what you think it is. It's easier to get close to this if you have a local model. You can take Gemma 4 and you can see precisely what goes into the context at all times. We always sort of have to trust data. We always have to trust the trained weights. But in the case of an API, Gemini, Claude, ChatGPT, or other, you also have to trust the API. And that's a different thing than injecting directly into the context. And that's important. If I could break this down into one simple notion, it is that the forward pass is a context, admitted context to logit field. In other words, it takes admitted context and returns logits. There is no randomness in this process. That's the key. So we will talk about why this is deterministic and where the randomness comes in to the process. The full rigor and definitions you can find sort of on my GitHub. And here's the payoff for that. The models have no root of trust. So root of trust is enforced by generally a TPM chip, a secure enclave on your phone. Most vendors have those things in their hardware. We rely on them to protect our keys. They are the base trust that no one can get a crowbar under. They are what lets us know we loaded the operating system we think we loaded. We loaded the environment we think we loaded. We are running the software we think we are running. Without this, we cannot trust the primitive. And models do not have this. Every token that enters the context perturbs the geometry equally. It's the system prompt, your system prompt, Google system prompt, Anthropic system prompt, jailbreaks, all condition the geometry equally. There are no protected tokens. There is no protected geometry. It is all the same. So the models do not have it. Yes.
Can I ask what might be a really simple question?
Absolutely.
So for folks who are let's say we have a lot of people who've been joining this program who are software developers and others, but when they're starting to think about, especially individuals who are hoping to be, acquired by enterprise down the line, and people who are building on top of, I don't think anyone in this call, I would not define any of them as wrappers, but let's say they're trying to decide what model to build on top of. And ideally coming out of these sessions, they decide that they want to build on top of a Google model. But what should folks be looking for, since we don't know exactly what you or Anthropic or ChatGPT, like we don't have full insight into how the models are being developed, and it seems like there's new models coming out all the time. How do you, beyond just, the output that we can see, what kind of diligence should someone be doing into the model to decide which one, which company and then which specific model they want to be building on top of?
It's a very good question, as a matter of fact, Colin. It's for me, it's quite simple, and I know this is being recorded, so I will sort of keep my answer somewhere down the middle. When I think about this problem, I think about a use case. I want the best, fastest, cheapest model that matches my use case. Now, what does that mean? It means I define the operational parameters of my use case. I test models against evaluations, and I decide which model appropriately meets those needs. Now, you could always throw 4.8 at it with maximum dwell time, with maximum thinking tokens. Claude, it's a phenomenal model. And you'll probably get pretty good results. It's very expensive to do that, right? Generally here, we're trying to build a business, not build a funding event. If you're trying to build a funding event, that may be okay. If you're trying to build a business, you're thinking about, do I make money doing this? So not only do you have to think about the performance of the model, but the cost of the model. And that's sort of when the Gemini family starts to look very interesting, because we have models that sort of define the Pareto frontier, or if you look at this as a sort of multidimensional variable optimization problem, cost versus speed versus capability, the Gemini family looks very attractive. So from 3.1 Pro, which is has high intelligence, requires more reasoning tokens generally, so maybe a little bit slower, but very conversational, all the way down to your Flash models that are very fast, very efficient, very cheap. If you're writing Python functions to do, sort of whatever, you might not need a Pro model. You could do it with a lighter model, like the sort of the middle tier model, which is our Flash models. You might do it with an open weight model like Gemma. If you're in a scenario where, here in the United States, we always assume, oh, I have a high bandwidth connection to the internet at all times, so I can just call an API. In many places and in many use cases, that's not the case. You might want a very strong local model that you can run on the edge in disconnected cases, or in cases where you don't need to go to the cloud. Gemma 4 is an outstanding model for something like that.
As an example, Dick Moberg just joined our call, and they are going to be, sorry to call you out, but I'm also trying to, we have 180 portfolio companies, and people are in all different stages. So I'm trying to make this as useful for the folks who are in the room as possible.
Certainly.
So Dick Moberg joined the call, and for them in hospitals, and Dick, please correct me if I'm not reiterating your previous comments accurately, but they can't necessarily put everything into the cloud. So where they are. So was my understanding of that accurate?
Yeah, we're using a cloud model, and sometimes we install that within the hospital, just behind their firewall. But some places now want it out there. I'm sorry I came in late. I thought
No,
we were starting
you're
at
good.
11. But it's very interesting for us. Thank you.
So, how would they go about, like, deciding a model versus Jacob, who's on our call and up until today had perfect in-office attendance.
Up until the tornado.
They're working, till the tornado. They're working more with restaurants and others. So, for them, they might be looking for something different. So when we're thinking about, like, security and data, I think one question that I just I've been waiting to specifically ask you is, how do you choose what model, based on, everyone here is, still in kind of startup. So they want to make sure that they're not burning cash, but they still want to make sure that they're being, really secure with their data. And, I come from operational resiliency at a financial firm before coming here. So my hypothesis is that the company that ends up being the one that doesn't break down is going to be the one that lasts. I
would say.
Yeah. I'm wondering what your thoughts on this are from a security posture.
Well, so, okay. That's okay. That is a complicated question. Let's break it down into pieces, because there's multiple parts there.
Okay.
So data residency, HIPAA compliance, behind the firewall, API, who you trust as a partner plays into all of this. I don't need to sort of go into credentialism here with GCP. All of the hyperscalers have this level of credentialism, right? Azure, I worked in Azure engineering for 10 years, is a fine product. AWS is a fine product. GCP is a fine product. Can we build your system on GCP? Yes, we can. There is no question about that. So we build all our own systems on GCP. It is absolutely and utterly capable of building any system you could devise. So are the others. So it's not a question of, and indeed, in most cases, you should be on all three clouds. You should build your system so it can move from cloud to cloud. So it is containerized and runs in Kubernetes, GKE, and can move, because from time to time you will encounter a customer who is shockingly not on GCP and doesn't want to migrate to GCP to host, sort of your solution. So you need to be where your customers are. And that means building a solution that works on GCP and other platforms as well. So that's sort of the platform that defines that. It's got all the data residency, all the encryption, all the HIPAA compliance is a partnership, as you know. It is we provide tools and capabilities that can be made HIPAA compliant. It is a partnership with our customers that actually use these tools and services in a HIPAA compliant manner. And so that you can look at sort of the list of systems and how they relate to HIPAA compliance, and then if you behave in the manner in which you should, all should be well. So much like security. So we secure the cloud, you are secure in the cloud. That is the covenant we make with our customers in that regard. For models themselves, we do have open weight models. You'll notice I don't use the term open source. There are no open source models that I have seen. Open source means I can go to your GitHub, download your data, reproduce your results. Well, okay, that's not the case. So you always have to trust the trained weights when you pull an open weight model, whether that's Llama 3, Gemma, Quen, whatever model you choose to DeepSeek, whatever model you choose on the open weight family side, you trust what's in Theta. You don't know, it's inscrutable. You can modify it, you can fine tune it, you can add adapters, you can do LoRa, you can do as you will. to perturb those weights, but at the end of the day, you don't know what's in them. So Gemma is a fine model. It's highly intelligent. We also have a model called MedGemma that's currently built on our Gemma 3 architecture, but it is also a fine model, and that one is tuned to understand medical terms. As long as there are no follow-up questions about medical terms, which I know nothing about, any of it's not my field. But I know it's very good at talking about medical stuff, and I wouldn't characterize it personally beyond that. But we do have Len and I have teammates who work specifically in healthcare, and we can bring them to bear to answer absolutely specific questions about how MedGemma will fit in your environment and how Google Cloud works in the medical space. I will say, as a local model, Gemma is outstanding.
Okay.
You don't have to send data to an API. Now, protecting the base model is the same. Protecting the geometry is the same. But Gemma is there, and then Gemini for what you can send. Oftentimes, a hybrid model will work. Many sort of use cases don't need entirely a local model. They can send some reasoning or some work to the cloud. And so oftentimes a hybrid model might work, where one of the more powerful Gemini models could augment the local, smaller, open weight models. Does that make sense in terms of your question? Yeah.
Yes. Does anyone have any questions on this before we move on? Okay, cool. Thanks, John.
Yeah, one more piece I will mention here because this is important. There are a couple of different ways to interact with the Gemini models, and in fact, many of our partner models. So you can run Claude on Gemini Enterprise Agent Platform. There are many models, third-party models and partner models in what we call Model Garden on what was formerly known as Vertex AI and now known as Agent Platform. So any model that's on Hugging Face, you can pull in Llama models, DeepSeek models, our partner models like Anthropic. You can use the OpenAI open weight models on our platform. So it's not just Gemini. You can pull the model that is most appropriate to your use case and what you need and use those models. Gemini is a great option in many cases, but may not always be exactly the right answer, precisely what you need. And so I want to make it clear that our platform is very, very open to the use of any model, in fact. Okay, so with AI Studio, you can go and you can use it for free and you can get an API key. It is a great place to test out our first party models. But in the case of HIPAA compliance, medical, financial, you want to be on Gemini Enterprise. You want to be on Agent Platform. This is where you are going to have the full power of GCP. AI Studio allows you to deploy on top of GCP, but it has one deployment difference in that it is through a global endpoint. What that means is GCP handles the traffic shaping. Okay, if that's all right for your use case, wonderful. However, for data residency, for HIPAA compliance, a global endpoint is probably not what you want. You want to be able to control the traffic shaping. You want to be able to control where data sits, how it is encrypted at rest, how it is encrypted as it moves. And so you want to handle everything yourself. And that is where Gemini Enterprise comes in and where Agent Platform comes in. That will give you the comprehensive end-to-end AI and ML platform to build the sorts of high compliance and high regulatory environment systems. So when you and we do have a consistent API now, which is nice, and SDK, so you can sort of move back and forth. But if you're kind of wondering, hey, I use AI Studio, Google AI Studio, AI.dev, and I'm also using Agent Platform, formerly Vertex. What's the difference? So this is the difference. They both deploy on top of GCP, but one gives you many more capabilities in terms of dealing with regulatory and high compliance use cases. Does that make sense for those pieces?
Makes sense to me. Does anyone have any questions?
Yeah, questions about that.
Okay.
Excellent. All right. Nope, that's you seeing me. So now I want to, okay. So should I just have it said? All right. We can sort of go through this in a little bit less detail, it sounds like we would maybe like. So the motivation here is simply as an analogy, what you deploy in a model has no kernel mode. So if you're used to using an operating system, you're used to a system where there's user space and kernel space. This does not exist in the models. So way back when, if you're old like me, you remember when you could hit Control Break or Control C, list, and edit the code, and then run, and it would just run. So you could imagine if you could somehow break your Windows machine and list the kernel code and then modify the kernel and then run, and your Windows would continue to run, you wouldn't probably want to use that system for financial data or healthcare data. It is the kernel mode that protects our ability. That is our root of trust that is founded in generally a secure element on your hardware like a TPM chip. So this is the secure trust that gives us secure boot, and then a secure operating system that gives us kernel mode. Ring 0. Models do not have ring 0. Prompts are prompts. Initial conditions, system prompts, prompts you give, RAG, images you show the model, it's all tokens. It all goes into the same geometry. It all conditions the inference substrate. There is no getting around that at the moment. There's no getting around that at the moment. You might be thinking, okay, how does this relate to kernel mode and user mode? There are no privilege escalations in the model because there are no privilege levels. Everything is equally privileged, and that's the point. I'm not sure this would be particularly interesting. This is how the models work. At inference time, they are deterministic dynamical systems, right? I think calling from your questions, this might not be as valuable for the founders. I would just say what this math means is it takes in context and emits logits, which are probability weighted continuations. That's all this sort of says. Does that make sense?
Yes. Thank you.
Okay. All right. The model itself is deterministic, and this is what's important. Temperature, when you set that changes the logit that we take. So the forward pass is deterministic. You put the same inputs, you'll get the same output. When we take the logit and we apply hyperparameters on top of that, top K, top P, temperature, we don't take the top logit anymore. So we choose probabilistically from the top set of logits, and then we decode that into a token, and we return that token into the next forward pass. And that's where randomness comes in. Okay. So if you set your model to temperature 0.0, it will pretty much, other than say IO noise or very, very small perturbations of the weights, return the same values. And so that is the main point. This is where sort of the community gets it very, very wrong. Stochastic parrot sounds nice, but if you want it to be correct, then the mathematics is this for the model core, and this is our primitive. The decoding policy is where the randomness comes in. So K-phi is generally how we would refer it to, you will see the literature refer to the decoding policy. So this is where we decide which logit to take. The important part here is that sampling is not agency. So what does that mean? The model is not telling you any deep truth. Truth does not live in the model. The model has no idea what's true or false. It is a locally coherent continuation only. True, false, right, wrong, all lives in the governance. layer above the decoding policy. It's what you think of the result that matters. Model has no clue. It is simply returning a locally coherent continuation based on the token's input that it is given. That is what it is doing. And that's where the layer of governance comes in. Your interpretation of the output is what gives it true, false, right, wrong, accurate, inaccurate, in governance interpretation. That could be a human, in the case of a chatbot. That could be evals or testing in case of an agent. Whatever it is, whatever your governance regime is, if it's a hospital, if it's financial, if it's the laws of the state of Philadelphia or the United States, right? That's where governance comes in, not in the model. The model doesn't; those don't exist at the model level. They all exist in the engineering above that. So the point being, right access to context is engineering control. And that's what we'll see. That's what this says. This is just a little bit more sort of rigor on top of that idea where I motivate the agent on top of the model. So this is sort of the payoff to the big sigma notation. Big sigma is the trajectory over many tokens, over many inputs, over many rounds. So when you have a conversation with Claude, you do round after round with Gemini, that is a series of tokens perturbing the geometry that result in a trajectory that upon which we build an agentic core. And this is sort of the idea and the shape of this notation. So you have the model core, that's a deterministic map. You have the decoding policy on top of that. The context is what goes into the admitted context goes into the forward pass, and that results in sort of this trajectory over which we apply governance and decide how much we like the output. Does that make sense? Questions about that? Okay. I don't think this will be particularly important. Here it is when we sort of look at when we look at these sorts of attacks. So when we talk about how we're going to attack these models, it starts to be about motivating reachability. What can we cause the model to do? That's what we're trying to do. We're trying to perturb it with adversarial tokens in one way or another and cause it, modify the reachability set, modify where the model goes to result in a continuation that was unintended by governance. This is a jailbreak. This is how we attack your model. This is the idea. The important part here is that text is not a guarantee. You can tell the model, do this, don't do that, allow this, don't allow that, say this, don't say that. None of that is a guarantee. None of that is enforceable. If your root of trust is a prompt, your root of trust is text. It's useless. You cannot yell loud enough to prevent perturbation of the continuation. Okay, and
so John,
sorry,
then
yes.
what would you do to prevent that? So, I'm even just thinking like, so Jacob, who's here with like Zeppler, and it's it's primarily dealing with like restaurants, but like you might, as someone who doesn't work for Jacob's company, I might think that, okay, that might be a company that could go with something like a little bit less robust. But at the same time, if his, for lack of a better term for me, if it gets corrupted and starts saying some really crazy stuff to your customers,
That's right.
And then it's in the news, I mean, I just feel like everything
You're right.
needs to be more secure than maybe you would think. So
what do we do about this problem? Absolutely.
Yeah.
Great question. Great
and
question.
is that something that you would recommend that, like, let's pretend that everyone here can't afford to have you come and be constantly watching how, what are some, is there, what are your recommendations?
Absolutely. So let's sort of assume the basis of the problem and start talking about what we can do about it. Building agentic composites that are secure. We just talked about the model. We understand that it's a primitive. So let's talk about the engineering we put on top of that. And that's where we turn logics into agency. This is where agency comes from, right? This is where actions come from. This is where we're turning knowers into doers. That's what we want to do here, right? LLMs are tremendous knowers. We're trying to turn them into tremendous doers, right? So we build on top of these models a bunch of engineering that give it agency. We use agent development kit. We design our agents. You might have for your restaurant, you might have various different agents, or your hospital, you may have different agents or software engineering components that use the models. That is the engineering piece. That's where we take the output of the forward pass, the primitive, and do something with it, turn it into agency. It's the ecosystem that gives that reach. Okay, and this is where a lot of mistakes are made. The reach. Claude dropped my production database and the backup in the backup. Okay. Well, if you brought that into my office and said, "Hey, John, an intern just deleted our production database and the backup at the same time," I would go, well, how come the agent had access to our production database to drop it in the first place and had access to the backups of the production database so to drop it in the same script? In the community, you will see, look what Claude did. You will not see, or look what Gemini did. You will not see, hey, my system allowed access to both of these things and didn't constrain the blast radius when I handed it to an agent. So it is the ecosystem that gives these models reach. APIs, workflows, permissions. That's when you have to start thinking about, what do I let survive? Architecture decides what of that reach survives. What do I allow this thing to do? How do I control permissions? How do I control the architecture around these components to make sure as that they do what they are supposed to do and not what they are not supposed to do? And that's the key distinction. And the failure mode that you will see is very, very simple. It's a little bit harder to say even than it is to understand. When you give the model ecosystem reach without architecture control, you fail. My model dropped my production database. Why was it able to do that? It shouldn't have been able to do that. That's the simple answer. And we've been engineering things this way for a long time. So when you think about the actual failure itself, is not that your model was too smart. It's that you gave it too much reach. So how do we, to build it securely, we constrain the reach. We build a cage. So what does that look like? And this was motivated in the prior talk. I'll motivate it here again because it's very important. The model cannot validate itself. And more importantly, the model cannot validate the composition, the agent. Why did you do that, Claude? That is a locally coherent. Why did you do that, Gemini? That is a locally coherent continuation. It has nothing to do with the state of the world, the state of the geometry, the state of the conditioning of the geometry, the state of the context of the model, the state of the world at the time it dropped the database. It is just an ex post facto story that should be locally coherent. It has nothing to do with actual reality. Governance, it should reject it at all costs. It is not in any way, shape, or form confession. It's simply a locally coherent continuation. The model cannot validate the composite. We talked about root of trust. This is highly practical, if somewhat difficult. Generally, I will see agents being built with functional decomposition. This typically is the wrong approach. I will talk about why that's sort of the wrong approach, but let's talk about what it is. Nobody expects to hire a person in their company. Welcome to Acme Co. Here's a 10-minute briefing of what our company does. Now go act autonomously in our environment, which you have no clue about, for the next 6 months, and make sure you do it accurately. Make no mistakes. We'll just tell the person we hired, make no mistakes. That's the only stabilization we give it. And yet somehow, rationally, we think, oh, agents will be able to do this. They won't. Okay? So you can't just establish an agent, give it a system prompt, turn it loose into an environment you think you understand, which actually you don't, and expect it to operate autonomously. With humans, we actually select the opposite. How long are you going to work on this project before you ask for help? Well, I really like to dig into things, so I'd probably work on it a good 2 or 3 weeks before I went and asked anybody for help. It's like, well, thank you very much for your application, but right. So we select for precisely the opposite among humans, right? And yet our expectation of agents is different. These are the 3 things every agent does. If you break down every workflow you have, every agent, everything, it does these 3 things. It interprets the world. I'm using a log parser as an example here, but all things do this. It understands the rules. What do I do? What are the rules? What's my interpretation? What are the rules? And then actions. What do I do about that? These 3 things. Every workflow mixes these things. So I summarize the logs, I cluster symptoms, then I look up the rules. What is the severity of this thing? What do I do in case of an error? What is the dependency graph? And then I take an action. Do I queue page somebody? Do I queue a ticket? What do I do? So what's going on? What are the rules? What do I do? Now, this will motivate you to build agents like a logging agent, a root cause agent, a remediation agent. Each of those agents, and this is perfectly rational to us, to build agents as if they were humans. They are not. Each of these agents has interpretation, policy, and action built into them. So when any one of those things changes, all your agents change. This is a horrible architecture. It not only ripples across every one of your agents, it ripples through all your evals, it ripples through all your testing, it ripples through everything. Every single change you need to make changes everything. This is an anti-pattern in software engineering. We never do this. We decompose by volatility. The same component should never interpret, understand policy, and take actions. If you have a component that does all 3 of these things, you are guaranteed going to fail. It will not work. The same biases that go into interpretation will go into policy interpretation and will go into action, right? Instead, you want to decompose by volatility. What changes? Why does every single one of my components change just to bring on a new customer? Right?
John, can I ask a question? Because I feel like I just had like an aha moment here.
Okay, great.
I feel like the way in which I've been hearing about, and in a lot of ways talking about agents for the past 3 years, was an agent as a human.
Yes.
So like we want an agent to handle email. We want an agent to handle just intakes. So,
yes.
And almost, so using it as almost a way of like, we would have had a person doing this, and it's
exactly,
so that's a little bit blowing my mind, what you just said, because it really, it undercuts you know, and
Everything.
and not just me, but that's how I was taught this by
Yes.
AI experts, I guess. So help me understand, like, what is, maybe this is a time for a complete reframe on
It is. Yeah.
what is the appropriate use case of an agent if I'm not thinking of it like a human. How am I supposed to be thinking about this?
Absolutely. So let's talk about that. So functional decomposition goes like this.
And guys, if this is not helpful to you, I'm trying to just like ask questions that I think might be highly relevant to other folks. But if people in the room are not finding these questions to be helpful, and you don't feel confident even saying it in the group, you can email me, you can chat me. I want to make this just as helpful for people as possible. So please, John.
Yeah, absolutely. Functional decomposition goes like this. When you're building a house, you don't build cooking. You don't go to where the kitchen's going to be, put a microwave there, run a wire out to the street, plug it in and say, okay, now I built cooking. Now I'm going to build sleeping. So I take a mattress and I put it in the dirt where the bedrooms might be. And now, okay, I've built sleeping. You don't do that. You have an architecture diagram. The architecture diagram is in multiple layers. It has a frame. It has a plumbing diagram. It has an electricity diagram. You build the frame. The reason why it's necessary to do this is because let's imagine we're now not building a home, but a skyscraper. Okay. Your plan needed to not only plan for the structure that you were trying to construct, but how to get concrete 1,000 feet in the air to build the 100th floor from the 99th floor. Well, if you get to the 50th floor and you don't know how to get concrete 500 feet in the air, how to get a crane up there, how to get your people up there, you've failed in your project because you didn't plan not only to build the thing that you were trying to build, the edifice, but the structure necessary to allow you to do that. And this is where the sort of agent as a human falls down. They are empowered to interpret what is coming at them, interpret the rules around that, and interpret the actions. We never have humans do this independently because humans behave differently. They have self-preservation. You know, lean over and go, I'm about to drop production. It doesn't quite feel right. Should I do that? And your friend leans over and goes, let's ask somebody. That doesn't feel right to me. They have this sort of self-preservation mechanism. If an intern came to you and said, you know, I read a 2-year-old Jira ticket that told me I needed to rename the production database, so I did. You might be a little upset at the time, but it's sort of like you would correct that individual and they probably wouldn't do it again, or they might indeed lose their job. But actually the person who gave an intern access to production should lose their job, but that's neither here nor there. But the point is, agents don't have those self-preservation. They're going to read everything in your environment. They're going to look at every bit of cruft you ever put in there, every old README that was never anticipated to be read by a human, everything you wrote 2 years ago to make your manager happy, every goofy thing that's in your Jira. They're going to read it all, and they're going to take it all in, and they're going to act on it. There's a million hidden control layers in your environment, in your business process that you have no idea are there. You think you know, but you don't. Because when I need to get something done, I don't go to Jira, look at the 25-step process and follow it step by step. I chat with Len and I go, hey, dude, help me out here. I know you know how to do this. What should I do? And he's like, yeah, let me do it for you. Okay, it's done. Sweet. That's the real business process. The 30-step process that never worked, that's not the real business process. Your process
click that someone created a couple of years ago.
Pardon?
The click by click that someone created a couple of years ago. Yeah,
that's out of date.
That nobody's ever looked at again.
Right? And just enterprise America, whether you are an enterprise or you're trying to work with enterprise, is this way. There are so many documents and byproducts, and just cruft is an old word. we used to call it that. It means just all this buildup that is meaningless in the present environment that a human would never go read. You'd have a good chuckle if your new employee came in and went, I read the thing you wrote 5 years ago about it. It'd be like, okay, that's great, but right. So it's sort of like you have this very, you have
Hey,
this.
John, can I just pause you for a second? I think Dick Moberg is having trouble leaving a comment. I want to just ask him really quickly.
Dick, what's up, dude?
He wrote me an email saying this is very helpful and timely, but I want to just make sure. Dick, do you have a question, or did you want to just give a shout out of this being helpful?
No, I don't have a question. I just wish Ethan were able to attend this. He's at another meeting. He's at a brain trauma meeting in Minneapolis or Milwaukee. But
that sounds more important.
Yeah, no, but we're no. This is important. We're right in the middle of kind of creating our agentic architecture. I loved your analogy about the house, and I wish Ethan could hear it. I think this is very good. So just a big
Len and
thumbs
I
up
would be
for this.
happy to jump on a call with you at any point. And that goes for everyone. Our job is to be helpful here. So this is not the end of this conversation, but merely the beginning. So reach out to Len, reach out to me, schedule a call. We'll jump on a call. We'll do an hour architecture session with you. We'd be happy to do that. So please don't think you need to write all this down or watch the recording 1,000 times. We're happy to help in any specific case that we can. That's the goal of our team. So we will make sure everyone on your team sees it.
And
Great, I appreciate it. Yeah.
On that note, this 6-part session was to kind of give you, it's been a lot of information about what Google has available, but that's exactly what this is supposed to be. You can start finding out who you can reach out to ask questions, to go deeper on your specific business use cases. I don't think Tom is on the call today, but he's been talking to Len. So the folks who are really, we're trying to show you what resources are available and what folks you can reach out to for specific questions, and also kind of, for me, I just feel like that last slide, I'm going to have to spend the long weekend thinking about how that has completely changed everything I thought I knew about this. But fantastic. And that's why I'm glad that we did this.
Absolutely. Absolutely. Think of the hospital environment, right? Okay. Every hospital is going to, you want to read PDFs, the medical records, they're everywhere. You're going to want to interact with Epic. You have to. You're going to want to interact with all these. So why would you change your agents that parse PDFs for every customer? They parse PDFs. They communicate with Epic. They do interpretation. They use MedGemma. Why? Because MedGemma is really good at interpreting medical documents. They don't use, a different model. None of that needs to change for a new customer. What needs to change, you're always going to do that for a hospital. What needs to change is the policy. What are the rules? Who do I call? Or the actions? Who do I call? Right? So interpretation, if you build it like you were saying, Colleen, where okay, now I'm reading emails, now I'm reading this document, now I'm reading that document. What happens when document changes? Every single one of your components changes. Right? And so you're not going to be a hero Monday morning going in talking about volatility decomposition. Believe me. Okay. So this is not like drop everything you were doing. However, this will do what you just said, Colin. It will rewire your brain a little bit. You will start to hear, you'll be sitting in meetings and you will at least hear and start asking questions like, wait a minute, what if that changes? What do I have to change? How do I bring on a new customer without changing every single agent I have? How do I bring on a new model without changing every single agent? Let's say Gemini X.X.X is very, very good at interpretation all of a sudden, right? We used to have MedGemma based on an older version of Gemma, where Gemini became better at medical terminology than the MedGemma. And so we retired the older MedGemma and our customers told them to start using Gemini instead. It's better. Well, now MedGemma 3 came along and that's better still. MedGemma 4, maybe. I don't know. Google DeepMind. I don't know the roadmap, but it's safe probably to assume. Whatever. Don't tweet that, please. I like my job. So it's sort of like when these things change, I just want to change the component that goes along with them. My email, my what tool do I call does not need to change when what I'm supposed to do when a triage that requires a cardiologist comes into my ER, right? Those two things have nothing to do with one another except for interpretation and policy, right? So if interpretation and policy is everywhere and action is everywhere, everything changes all the time. And you will never keep up, and you can't change models, and you can't evaluate anything, and you won't know how your agents behave because they all do everything all the time, right? And that's it. That's volatility decomposition in a nutshell. Okay. So how do I know if I'm ready to deploy? These are some of the practical things you were talking about. First of all, what is the blast radius? When these agents become compromised, what do I do? How do I know? What can they do? And what is the downside? Understanding the blast radius and some of those examples I was going to use from well-known kind of social media outages. This is the I dropped your database and your backup. Policy enforcement. Okay. What is controlled outside of the model? Where is root of trust? If root of trust is in text, this was another one of those examples. The security researcher who tweeted about the model, her claw deleting all her databases or all her emails, and she was texting it, stop, stop, stop. Okay. If enforcement lives inside your model, it's not enforcement. Text is not enforcement. Prompts are not enforcement. Root of trust is enforcement. ACLs are enforcement. Deny before allow is enforcement, right? Those are enforcement. You get a shock when you try and touch kernel mode. You get an interrupt when you try and touch kernel mode from user mode, right? That's enforcement. Please stop doing that is not enforcement. And irreversibility. This is an important one. When do I call a human? When do I'm taking an action that cannot be undone? Medical dosage, a deposit. Decimal points matter in our business. People's lives depend on these things working correctly. Software has had 50 years of engineering to earn trust. It used to fail locally, games, spreadsheets locally. Now software is everywhere. Lives depend on it every single day, all over the place. Well, that's because it's had 50 years of engineering to earn trust. AI has not been given this opportunity. It has been pushed into production by capital, into use cases we don't know if it's going to work well, into places we have to be conservative. Because when we take irreversible actions, people's lives might depend on that. Their financial life might depend on it. Their very life might depend on it. Decimal points matter in these use cases. If I'm building an aardvark with a funny hat and a cool shirt with Nano Banana Pro, it's not so bad if the hat's the wrong color. Okay, nobody's life depends on that, most likely, hopefully. But these are serious endeavors that require serious engineering because people's lives depend on it. And so when you're doing actions that are irreversible, you need to be very cognizant of that. All right, a refusal is not a stop. Stop, stop, stop. Okay. So here are 5 things you can do very practically. Scope by reversibility. If it can't be undone, a human's got to sign off on it. That's it. Right now, that's it. Okay? You've got to know what can be undone and what the blast radius of that is. Isolate your credentials. If I drop a scratch database or a test database, it's not the end of the world. If I drop production, it's a problem. So give the agent appropriate access, appropriate capabilities, and least privilege. Constrain it. Let it test, build the script, run a script on the scratch database, become highly confident that it works on the scratch database, and then have a human run it on production, right? That's credential isolation and scoping for reversibility, okay? Very straightforward. It's what we always do. Velocity limit, this is an important one. If I send out one errant email, okay, it's a mistake. If I send out 10,000 errant emails in 5 seconds, it's a breach. It's a problem, right? So throttle your agents. One of those those events that happened in social media happened over 6 seconds. In 6 seconds, the entire a bunch of packages got compromised, and then the supply chain was completely compromised, and before the vendor could react, right? So the velocity limits were not in place. The model, the agent was able to operate extraordinarily quickly and compromised many things that could not be undone in a very, very short amount of time, right? So don't let it do that. Constrain the velocity at which these things can act. Session containment is a relatively controversial one. When you persist memory, be very cognizant that you're doing that and be very careful about bringing it back. When you persist the state of the world and bring it back, it is not the state of the current world, and the effects can be destabilizing on your agent, okay? You don't want to destabilize your agent with inputs. You want to stabilize your agent with inputs. So memory coming back can be destabilizing. It can be an attack surface. Be very cognizant of how long you let cruft live in your environment. Purge it if you don't need it. Don't bring back ancient information. You see this in the harnesses that the labs build. That document is out of date. I should look it up again. Yeah, Colleen?
No, I don't have a question. I'm just looking
Okay.
at another screen. Sorry.
Oh, not at all. I thought you had come off mute. Okay, so be very careful about memory. I'm not saying don't use memory. Just be very, very careful of sort of how you pull it back, when you pull it back, and particularly when you purge it. Because 2 years ago, or even 2 hours ago in some use cases, is not the current state of the world. And then, of course, safe defaults. This is obvious. Default by deny. I don't understand this sort of claw attitude where everything is allowed, everything is, it makes no sense. It's devised and implemented by people who sell tokens for a living, quite frankly. Okay, this is interesting. This is the part of my own research. I call these ambient reachability attacks. These are attacks where point-wise, everything is allowed, but the trajectory is incorrect. The trajectory results in governance violation. Okay, what do I mean by that? My agent asked for a user ID. Fine, allowed. My agent asked for a database schema. Fine, allowed. My agent asked for an external IP. Hang on. Why are you asking for user information, for database, and an external IP? You're about to exfiltrate data. Each one of those steps was fine individually. If you look at any one of them, they might be allowed. But when you look at the trajectory, hang on, that's an attack. That's a compromised agent. That's a problem. Okay? So you not only need to understand point-wise what the agent is doing, but trajectory-wise, what fits within governance. You have to understand where the model is, where the agent is going, and what information it has. The attack I have from the other security database, in fact, since technically we're talking about that, I can just share this deck, which I don't usually have up, but I got to skip a whole bunch of let's see, these are cool, man. Jailbreaks. Okay, here, this guy. This image I made is an example of this. It's an image of a cat. Okay. And I put it on X and I say, okay, find the hidden message. Whoever finds the hidden message wins a Bitcoin. Whatever. There's a lot. It's a lot less than it used to be, but still a lot. Okay. Sorry if it was you. So the cat, you hand it to this cat won't work, by the way. This is a JPEG. The actual cat is a ping, but it does work. So just taking a screenshot of this will not be an attack, but it does work. Okay. So this cat embedded in it has stenography. And without going into the details of all the stenography, what happens is when you hand this cat to the model says, ooh, I see structure here. I should start decoding it. And when the model starts decoding it, what it decodes is instructions to the model. Oh, start decoding here. Start doing this. Emit this code. Then the model says, oh, here, run this code on this output. That will help us find the hidden message. The human's not going to read the code, and they can't read the binary output. So they just take the code, put it in their environment, and run it. And the net result of this back and forth between the model, who can perceive things in many different ways, in sort of multimodal ways. It can understand binary, it can understand the image, it can understand audio, whatever, not just tokens. The human is just looking sort of at a picture of a cat. It doesn't perceive that there are instructions to the model within that cat. And then the final output, the model tells you, I found the secret message. It's this picture of a cat, another cat. And you say, well, this is lame. That's not even my cat. You post it on X. Well, what the model actually did was create a JPEG of a cat with your environment variables embedded in it. So it has your API key in there. It has everything in your environment encoded in this picture of a cat. The model did what was helpful. It did what it's supposed to do. You interacted with the model as you were supposed to. You ran the code, and then you hit send on your X post, and all of a sudden you have exfiltrated your API key. Every point along the way, no violation. The only violation was when you sent the picture of the cat, because you operated in a manner in which you thought was valid, and the model operated in a manner in which it thought was valid, but it turns out it was not valid. And this cat doesn't actually exfiltrate your API key, but what it does do is condition the model to give a particular summary. So when you ask, how did you find the secret message, it will send a briefing that exfiltrates data. The attack is not the cat at all. It's the briefing when you ask the model, how did you do that? And obviously this sort of acoustic is not dangerous. It's got SECRET in the briefing. Okay, that could be your API key. That could be confidential information. So this is the sort of attack we have to worry about. These are the sorts of things that are going to start happening. All of your customers everywhere are starting to deploy these CLIs, these agents that are not secure. Those agents are going to be compromised, and they're going to dwell in your customer's environment for a long time, adversarially. And this is what's going to happen. So it's coming. Okay, we can go back now to the other questions about that. Ambient reachability, sort of this difference between how models perceive versus how humans perceive, this notion of a trajectory validation. Any questions?
No, I'm just really afraid now. So
Good. Then I've done my job. Okay. So engineering turns logic into agency. That's what that does. Architecture decides what survives. So that's how you have to think about it. What in my environment? What are my guardrails? What are my limits? What are my safety boundaries? Where does my root of trust live? When this thing gets compromised, what is the blast radius? What do I lose? And how do I recover quickly? Because if you've had an agent, a coding agent, compromised Codex or compromised anti-gravity or compromised Claude Code in your environment, working with your developers for 6 months, injecting adversarial tokens into your source code, how do you even begin to recover? What PRs do you read? How do you audit your code, right? The community is telling you stop reading your code, right? This is wrong. Stupid. Sorry, that's negative. Ill-informed. Sorry, but stupid. Okay, these things are asinine. They don't belong in medical. They don't belong in finance. They don't belong where people's lives matter, right? So make sure you can recover from a compromised agent. Don't just let it go wild in you or your customer's environment. Okay. So we didn't purify the model. We didn't make the model not attackable. What we did do is build intelligent engineering and architecture to constrain the downside without costing us the upside. Some upside, yes. We're not going to let the agent go crazy. Not yet, right? We're not going to let it do a million things overnight without being audited. We're not going to let it affect things that can't be undone. We're not going to let it prescribe medication or tell us about dosages or decide how much money I owe in taxes. We're just not yet. What we are going to do is use it for what it's good at: interpretation, understand policy, taking constrained actions, give us the power, and mitigate the downside. And it's very, very doable. So I didn't mean to scare you off of agents, Colleen. I meant to give you hope, in fact, that these things can be built in a manner where you don't fall into that 95% of AI projects that fail, where you fall into that 5% where you really understand what these agents are doing in your environment, how they interact, and how they can be controlled and constrained. And if you can't answer those questions for yourself, you certainly can't answer them for your customer. And if you can't answer them for a customer, there's no way a hospital is going to roll out your system. Okay, so that's we sort of diverged a little bit from our original plan, but I think that's okay. I think we're now here sort of at the end. I do want to be very respectful. I don't have I kind of do, but I can go for maybe the next 5 minutes on questions. But like I said, email Len and myself, happy to answer questions by email. Set up a call with us, happy to do that. We can go through this in detail in your specific cases. So please do reach out. This is not the end of the conversation with us, but indeed the beginning. So we are absolutely happy to help. Thank you so much for your attention. I know it is a long session today, and I know how busy founders are. So we really appreciate your time, and hopefully we've delivered some value back to you in exchange.
John, before I open it up for questions, I just want to make a quick announcement for folks. I think a lot of people who are on this call are going to be a part of the capstone presentation next Wednesday. Len is coming, a whole bunch of other people are coming. I sent out just due to, it sounded like today was just a bad day for a lot of folks with conferences and things. I sent out 2 separate times for Monday to kind of just go over run of show, expectations, make sure that you feel prepared. You only need to come to one of them. I put out 2 separate times so that you have a little bit of flexibility of choice. So I just wanted to bring that to everyone's attention here. So if you can pick one of those times, and if one of those times doesn't work for you, I have a good amount of flexibility on Monday and Tuesday. So I'm happy to work with you to find a time that works for you guys, because it really is about making sure you are all set up for success. So that's my only plug. Now I'm gonna let folks get back to questions with John. Anyone? I have a feeling the questions are going to come, John, when something goes really sideways.
It might be that people sort of need to think about it and think about questions and come back with questions. Completely acceptable. That's great. I hope it was clear. I hope it was no questions because it was all very clear, and not no questions because what the heck was this guy talking?
John, I thought it was very good, and
thank you, sir.
I'm just probably I'm at much more of a higher level running the company, and I need my whiz kid to probably review what you said, and then talk to our AI team and our developers and stuff on this. But I can tell you the timing is perfect for what we're doing. We're building sort of an AI platform or analytics platform, and just coming up with the concepts and early prototypes of kind of our first agentic offering. So it would be great to run that by you. So
yeah, we would love that. I completely agree. This is the moment when sort of planning or an interdiction now, or just sort of can save you a lot of dark alleys. And so happy to go do that with you.
Yeah, it'd be good. We actually are teaming up with UT Southwestern Medical Center in Dallas, and they've got an enterprise license to ChatGPT, which and they're looking forward to our project to be one of the ones that actually justifies them purchasing that. so we
won't take offense. I love ChatGPT. It's a great model.
Yeah, but I mean, the thing is, we're starting to put it together, and one of the things we're going to do is start to record what are the what are the questions people are asking, either voice or text to our persona called Clara, our agentic AI person. So we'll have a lot of feedback on that, and I think getting your thoughts on that. And like you said, we found, every hospital we go to is probably using something different.
Yes.
And we know a bunch that are using, Google. So we want to try to make this exportable. So
Absolutely.
thanks again. It's very good.
With pleasure. With pleasure. I'm glad you found it a good use of your time.
Hey, Len, quick question. Is there a way that you can send me an email with all 6 sessions kind of consolidated? And then, it doesn't have to be one, but just all 6 of them in one
the YouTube recordings of them?
Yeah. And then I think what I want to do is I've got a couple questions I might add, but if you have some questions around feedback that you're looking for, we can kind of make one consolidated email out to everybody, and then kind of see where folks might want to go deeper or just kind of find out our next steps. But this was really great, John. Len, I think we can stop recording. John, my mom was an abstract mathematician, so